action.
Greetings all. Tonight we're going after the diffuse emission nebula in the Seder region. Now, it's called the Seder region not because Seder is part of it. Seder is actually a big star that just gets in the way of the nebula that we're taking a picture of. The Seder region nebula is cataloged as IC 1318, but to be fair, the region that we will be taking is not all of IC 1318, it's just a part of that. But we're going to take the part that's sometimes referred to as the butterfly nebula. That's not to be confused with NGC 6302 or the bug nebula. It's a different butterfly nebula. But the Seder region hydrogen diffuse emission is roughly about 5,000 light years away from the Earth in the constellation of Cygnus. Seder, which will be prominently displayed in the framing tonight, is only about 1,800 light years from Earth, meaning that Seder is not actually out in the nebula. Seder is in between us and the nebula. Anyhow, the star Seder is roughly 12 times the mass of the sun, and it actually has about 150 times the radius of the sun. So that's a big old star. All right, the Polaris just came out. Telescope's pointed at it. It just popped out. You see it right out yonder. There it is, Polaris. So I'm going to go ahead and get the polar alignment done, and then we'll be off and running. Okay, here we sat out on my swimming pool deck, looking up at the stars, get ready to take a picture of the Seder region. All right, so let me show you how we're going to do that. Right up here, where it says marker 1 is the Seder region. And notice that if you run due north right out of the horizon, run right through the North Celestial Pole, then the Seder region is almost on the meridian. So it's not going to be too many more minutes before we have a meridian flip. It's approaching the meridian right here. But anyhow, let me show you what this looks like. Here's how we're going to frame it up. I put the center of the frame right there on the marker that I set, and notice that the camera orientation is 270 degrees. So this right here is how we're going to set up on the Seder region and try and take this picture right here. So I'm going to show you how we're going to proceed to do that. Right now, I just got polar aligned, and we're sitting right here pointed up towards the North Celestial Pole. So what we'll do is go from here up to this big star right there called Seder, where we will do our mount synchronization in focus. And then you see from there, it's just a really short hop over to where we want our center frame to be. I've got Seder selected on Stellarium here. So we'll go back to our framing page, and this button right here will import the coordinates of whatever object I have selected in Stellarium, in this case Seder, which is where we're trying to go. So it's already pulled in the coordinates. Now if I have an internet connection, which sometimes I do and sometimes I don't, it will go ahead and load the database picture of the star Seder into here. If I don't have an internet connection and it won't load, that's okay. The coordinates are enough to get where we need to go. Okay, there we go. It pulled in the star of Seder right there, so I guess I do have an internet connection. So we're going to go ahead and slew the telescope on over towards Seder. All right, so when I tell it to slew, it's going to make its best guess at going and getting on top of Seder. So here we go. And you see the scope moving right there. And I can tell you it is going in the right direction to point at that star Seder, that's a good sign. And notice again how it's going almost horizontal there. It's almost on top of the meridian. So it's going to cross the meridian any time, but hopefully we can get focus before it does that. All right, if any of you are wondering why do we need a Bahtinov mask, here's why. The Bahtinov mask puts these spikes across the stars, and the way you know you're focused is because this center spike right here, the one that splits this X, is exactly right in the middle. I'm going to call this in focus, so I'll take the Bahtinov mask off, and you see it puts the spikes on all of the stars. See how it does that? But the little stars, you can't really tell what it's showing you. That's why it's important to use a big star when you do your focus, so you get that those big old X's on your focus star. And if you notice the time on the app, you'll see that it's been several hours. Actually, clouds came in right after we got focused and before we could get on target. But those clouds seem to have moved off now. So I think we're ready to get on target and get going. So I'm going to show you how I did that. Earlier today, I built a target set that I want to use for the imaging plan. So I'm just going to call it up from right here. This button here, load target sets. So it's pulled up the plan here that I had set for Seder, and we'll go over that briefly. You'll see we're going to do 10-minute exposures. We're doing this target narrow band, so I've got HA03 and S2. We're going to go and get an hour on each of those, and then we'll repeat with 30 minutes. Notice that I've got start guiding turned on. We've got slew to target turned on and center target turned on. So to push this button, it's going to plate solve itself on over to that HA cloud and center up on the place we want it to be centered. Now I'm going to have to rotate the camera because the camera rotation is not going to be correct. So I'll let it go and get started on the first image, and then I'll stop it. We'll do a series of plate solves to get the camera orientation correct, and then once we get that going, then I'll let it run. So here we go. Oh, I forgot to hook up the PhD2, so D2. All right, PhD2 is hooked up, so now the mount controls PhD2 in our auto guider. All right, now we have to get the camera rotation correct, so we're going to go to plate solving, and this time I don't want to re-slew to anywhere because we're already on target. So all we want to do is the plate solve. And watch the camera orientation here. I don't think it's going to change because I think this is the current orientation, but we're going to plate solve it just to make sure. Okay, so remember we want our orientation to be 270 or equivalently 90. Either one of those would work. So I think I can get to 90 if shorter. So I'm going to turn it left 76 degrees and try and achieve 90 degrees on the orientation. So I'm going to stop the auto guiding. I'm going to go make that change. Then we'll plate solve and see if I got the orientation correct. Now here's how I'll do it. There's my camera rotator right here. So I'm just going to loosen this set screw up, and then we will rotate the camera to the left 76 degrees. So here we go. Let me see if we can get that done. Notice I'm rotating the entire image train. All right, I think that's about 76 degrees. So we'll go plate solve that and see how close we got. Now I moved, when I twisted that, I moved the camera off target a little bit, but that's okay. We'll get back on target later, but for now all I want to do is check the orientation. So we're not going to sync and we're not going to recenter. We're just going to plate solve for the camera rotation. Here we go. Looking for 90 degrees. Okay, I got pretty close. I got within 1.3. So I'm going to twist it back to the right just a frog's hair, and we should be really close to 90. All right, I made a slight adjustment back to the right. We're going to plate solve and see, did I achieve 90 degrees this time? Watch it right here. 89.2, so I'm 0.8 degrees from where I wanted to be. I think that's about as close as I'm going to get it, so I'm going to call this good. Right here, we're taking our first of 6 HA, 600 second exposures. It's off and running, so I'm going to let it run, and I will come back and review the first hydrogen alpha that comes in with you. Yeah, that's not good at all right there. Something's going on with that. I suspect a cable snag. I'm going to go check that out. Okay, I tell you what I think was going on with that guiding. I calibrated the auto guider before I rotated the camera. So since I rotated the camera 90 degrees after I had calibrated it, then it doesn't know what it's supposed to do. It's like 90 degrees out when it tries to put the input corrections in, and that's why the guiding was going crazy. So I'm recalibrating with the correct camera orientation, and I suspect that when we try it now, the guiding's going to be fine and it's going to work as advertised. So I think that was a problem. I rotated the camera after I had calibrated the auto guiding. So lesson learned tonight, and we'll know that moving forward. All right, that's much better, much better. So now I will be back with you to look at our first HA frame in about 10 minutes when it comes in. Okay, I want to show y'all something while we're waiting on our first 10-minute image. If you notice here, this picture you're looking at now was the 1 second shot. Actually, it's a 5-second shot that was used in our last plate solve. I think it's noteworthy to see that in just a 5-second exposure, you can see some of the details of this cloud of gas that we're imaging. That's just with a 5-second exposure. So I can't wait to see the 10-minute exposure. We've got another 50 seconds. Okay, I sped up time, so now we've got another 7 seconds for our first 10-minute hydrogen exposure. Let's watch it come in together, coming in about right now. There it is. How about that? How about that? Look at the detail. I got to tell you, I'm happy with this. See these black things here, the clumps of dust and gas. Those are called Bach nodules, and one day those things will collapse into and ignite into a star. So this is probably one day will be the birth of a new star right here. And we see those things all up. Well, that's a bug, but still there are others out here. All right, here we are back on night 2 to film the Seder region. I've got the telescope all set up. You see it here. It's pointed up towards the North Celestial Pole. I'm just waiting on the North Star to come out. As soon as the North Star comes out, we'll get going. Everything is all set up and ready to go. So here we are running on Seder night 2. Notice here that I've got starting off with some O3 of 5 of those. That's because the other night we got a bunch of HA, a bunch of S2. However, when we were shooting the O3, a bunch of clouds rolled in, so I don't have as much O3 as I have hydrogen and sulfur. So we're going to start the night with O3, 5 frames just to even that exposure up, and then we're going to be off and running on HA, O3, and S2. 4 seconds until our first O3 exposure of the night comes in. Let's watch it come in. Coming in right about now. And there it is. So you can see not a lot of O3 signal, just like the other night. But there is some. You can see it right in through here. Okay, let me show you what unfortunate set of circumstances occurred on night 2. On night 2, here is the Seder region right up here. I had the Seder region dialed in. We got right on target, and we got going pretty cleanly. The problem is I messed up the camera orientation. The camera orientation was 45 degrees out from what it needed to be, and I didn't notice that. So all of the images we got on night 2 of the Seder region are probably going to be unusable, because if I get a bunch of images with this orientation right here, and then if I take a bunch with the orientation 45 degrees out, then when you stack those up, because you see here the sensor is not square, but when you stack those up, there's going to be a lot of extra space on the edges that's all messed up because the pictures didn't align, and we would have to crop probably half of this away. So because of that mistake, I'm going to have to repeat night 2, but now the camera orientation is correct. All right, the first HA image just came in. There it is. You can see it right there, and it looks pretty much like we thought it ought to. It's going to take 6 of the HAs. Then it's going to get some O3, S2, and then start over. And I'm getting the bulk of the O3s on the second run, just because the sky is going to be much darker then. I think those pictures will be better. So I'm going to let it run. We might come back and review an O3 and an S2 as they come in, or we might look at them later. So I'll be back with you in a little while to see what's going on. All right, let's watch another one come in. You see here it's coming in about 3 seconds. It's also an HA, so it should look very much like this one, but here it comes right now. And there it is. It looks just like the other one. You see it shifted just slightly a little bit because of dithering in between frames. So I'll be back with you when some O3 and some S2 starts to come in. All right, here comes our first O3 image. There it is right here. And you see it's a lot like those other ones we looked at the other night. Not much signal there, but there is some. You can see it right in through here. So again, when we stack these and clean up the noise, we'll be able to see some signal to contribute. But that's our first O3 image of the night. I'll come back when we get a S2 image coming in. All right, back with S2 image. Here it is. It's actually the last of 6 that just came in. I wasn't out here in time for the first one, but so this is the last of the 6 S2 images that we took. Again, more signal than the O3, not as much as the HA, but exactly what we expected. This is looking pretty good. A little more signal maybe than we were getting from the S2s on the night 1. So this is definitely going to be an improvement to the image. And unless anything weird or strange comes up, then I will see you at the end.